Covalent bonding. For this worksheet, you're going to make drawings just like the example here, and there are more examples in your reading, which I'm going to go through with you right now so that you see what it is that you're supposed to do. Let me go over this one real quick. You draw two dot diagrams of the elements in question. So in this case, it's H and Cl. Now I recommend that you put dots for one and X's for the other. Go ahead and do this for this exercise so that you can see what's going on. So a dot for H means it has one outer electron, and I know that because hydrogen, H, is in group 1 on the periodic table, so it has one outer electron. So I put one dot for hydrogen. Chlorine is right here in group 17. Remember, the last digit of the group number tells me how many valence electrons there are, so it has 7. So I put 7 X's around chlorine. The rule of 8, or the Octet Rule, says that an atom is most stable if it has 8 outer electrons. Right? It can either get those 8 or it can empty out its outer level so that the level before that is stable. Now in this case, since we're doing covalent bonding, they're not going to empty out anything. They're going to share. So rather than hydrogen giving this electron to chlorine, it's going to share this electron with chlorine. That's why we have these circles here showing that hydrogen's electron is in a circle for both hydrogen and in a circle for chlorine. So that electron from hydrogen is being shared with the hydrogen atom and the chlorine atom. If hydrogen is going to share one, then chlorine will also share one back. Atoms always share equally in a covalent bond. So if one shares one electron, the other one will share one electron as well. If this one were sharing 2, this one would share 2. So in this case, chlorine has 7 electrons. 1, 2, 3, 4, 5, 6, 7. It needs one more to make its 8. I want you guys to remember, if I ate, I'm full. Like if I ate food, then I'm full. Or if I have 8 outer electrons, I'm full. So here's 7. If I get one more shared from hydrogen, then I'm full. Now hydrogen's a little weird though. Hydrogen only has 2 outer electrons, and I put that here in the note. Hydrogen only needs 2 outer electrons to be stable because it's in the first period on the periodic table, which you can see only has hydrogen and helium in it, which means this first period can only hold 2 electrons. So hydrogen and helium are the 2 atoms that are stable if they only have 2 outer electrons. Most of the other ones on the periodic table, make sure that you get them up to 8. Okay? So let's look at some of the examples from the reading materials. Here we have 2 hydrogens coming together. Remember, hydrogens are happy when they have 2 outer electrons. So since this hydrogen has 1 to share and this one has 1 to share, then if they are both sharing that 1 electron, then they both are going to be stable with those 2 outer electrons that they're sharing. Chlorine has 7, so it needs 1 more. So if I put 2 chlorines together, this one has 7, this one has 7, each one needs 1 more to have 8. So if this one shares 1 with him, and this one shares 1 with him, then they're both going to be stable with 8. So as you can see, this dot from this chlorine and this X from this chlorine are shared in the middle between the 2 chlorines. Here's HCl again, which we already looked at on the worksheet. All right, where this hydrogen shares with chlorine, chlorine shares back with hydrogen, chlorine has its 8, hydrogen has its 2, and they're both stable. Now it gets a little bit more confusing when we get into more atoms. So if I were to bond NH3 and make ammonia, NH3, it's going to take me 3 hydrogens and 1 nitrogen to make ammonia. See how H has 1 outer electron and it wants to have 2. Nitrogen has 5 and it wants to have 8. So if I take 3 hydrogens, since nitrogen needs 3 more, and I've got 3 hydrogens to bond with it, if I put a hydrogen on each side that can have another electron in it, then this hydrogen can share 1 with nitrogen, this hydrogen can share 1 with nitrogen, and this hydrogen can also share. So I put one of my X's on each side from nitrogen so that it can share with a hydrogen in each spot. You'll do one like this with carbon tetrachloride, CCl4, on your worksheet. So anytime that you have a compound like this where it has a single atom and then more than one of another nonmetallic atom, what you do, put the one that's singular in the middle and put the one that there's multiple of around it. So if I had something with a 2 here, then I'd put one on each side. Something with a 3, you can see I put it on 3 sides. If I had a 4, I'd put one on all 4 sides so that it could share all the way around. Here for oxygen, if I take 2 oxygens, each oxygen has 6, 1, 2, 3, 4, 5, 6 valence electrons. So each one needs 2 more. So if it needs 2 more, it's going to share 2, because in order to get another atom to share with it, it also has to share. So see how I've put 2 of these dots on the side of oxygen nearest the other oxygen atom. So I put 2 X's on this side closest to this oxygen atom, so that both these 2 from this left oxygen and these 2 from the right oxygen can be shared in the middle between them. So when I put this circle around this oxygen, it has its 2 original right here plus the 2 shared, and if I count them all up, 1, 2, 3, 4, 5, 6 original, 7, 8 with those 2 shared. And the same thing goes for these 6 X's, and the 2 dots makes a total of 8 outer electrons. I put in the notes, when determining how many electrons are being shared between the atoms, look at how many electrons each atom needs to become stable. This will also be the number of electrons that atom shares. What I mean by that, when chlorine needed 1 more to become stable, it shared 1. So this one shares 1, this one shares 1. When oxygen needed 2 more to become stable, it shares 2. So this one shares 2, this one shares 2. If you needed 3 to be stable, then you would share 3. And here I'd have 3 dots and 3 X's. So however many it is that you need is how many you will share, and you end up with that many shared in the middle so that both of them are stable. This double bond can be written as such with 2 lines. A single bond would be 1 line, and this is called a double bond because they're sharing 2 pairs of electrons. So we put 2 lines between the O's to let you know that there are 2 pairs of electrons being shared. Again, I know this is kind of an odd worksheet that you're working on, but as you go through, draw out your 2 dot diagrams. So put a dot diagram with dots, a dot diagram with X's, put a plus in between, and tell me what are they going to become after they bond. Put the number that need to be shared in between so that you can have circles around both of them, and make sure that you don't put any extra dots in here. If hydrogen only has 1 dot, then it should only have 1 dot total. If this has 7 X's, make sure that you only have 7 X's total. The 8th comes from the shared one from hydrogen. I know some people will try and put an extra X in there to make it so chlorine has its 8, but don't give chlorine more than 7 X's because that's all chlorine has to give. So share as many as you need to make that 8, or 2 in the case of hydrogen. And if you still have questions, please feel free to come ask me.